this section, we will work with function notation and graphs. We will also be introduced to some non-linear functions. First, a review of function notation. When we state f of 3 is 5, we are referring to a point on the graph of f of x that has an x-coordinate of 3 and a y-coordinate of 5. Here is an example that uses function notation. The first two parts are asking for the y-coordinates that go with the given x's, while the last one is asking for the x's that go with the given y-coordinate. Focus on the points on the graph of the function that help you answer these questions. For the first one, f of -1 must be -1 since there is a point on the graph with an x-coordinate of -1. The second problem has us looking for a point with an x-coordinate of -5. On the graph, we see it corresponds to a point with the y-coordinate of -1. Third problem, find all x's that have y-coordinate of -1. We see 3 of these points on the graph. Reviewing the linear function f of x equals x, this is oftentimes referred to as the identity function since y equals x, and therefore all the points on the graph have the x-coordinates equaling the y-coordinates. Domain and range are all real numbers. Here is a nonlinear function, the quadratic function. We will spend more time on this function and its properties later in the semester. For now, understand we have a U-shaped graph, referred to as a parabola, with a domain of all real numbers and a range of all values greater than or equal to 0. On the next one, we have a radical or square root function. It is actually half of a parabola on its side. In order to have real output, our domain needs to be greater than or equal to 0. And last, the absolute value function. We can put anything in for x, but since absolute value makes negatives positive, our output is greater than or equal to 0. We will use these newly discussed nonlinear functions in our next section. Thanks for listening.